So I'm going to talk about the multiple life model, and this is part two: annuities benefit and Thiel's differential equation. So when it comes to annuities, so big one, annuities. So with the annuities, the characteristic of the annuity, it pays for being in a state. Characteristic pays for being in a state. And the case, let's say, let's discuss the continuous case. For the continuous case, you have a bar x I j will be equal to the integral from 0 to plus infinity of t p x I j dt, and you discount it back to today. So this is that the value of the annuity is equal to the integral from going from one state to another, discounted back today. Uh, Now the same, so a bar x00, for instance, a bar x00 will be being in a state, being alive. It pays for being alive, pays for being alive, uh, for being alive. A bar 01 pays for being dead, pays for being dead. So these are the annuities. Now when it comes to, and also the discrete case, so discrete case, you have a bar x I j, a du, okay, let's say a du x I j is the same as saying that it's like the sum of kpx going from state I to j discounted back at k going from 0 to plus infinity. This is the discrete case. So about the discrete case, let's discuss a recursion relationship. Recursion relationship. So with the discrete case, if you have a du x I, so a du x I is the same as, because it pays for being in state. So you're already in state I. So you already have $1. And now you are going to transition. So 1 year from now, you are you have a survival probability of going from state I to state K, and now you go back, you come back from state K to state I at age x plus 1, and this is discounted back today, and I have to sum over all the possibilities of that happening. So this is what you have for 1 year recursion of and also k goes from 0 to n. Now age x I j. At times you at right now you are in state I. You are going to state j. You're not there yet, so it pays you 0. Now at time a x plus 1. Okay, I forgot to put the u here. But at time plus x plus 1, you are moved to state j, but you have to pass first in state k, and I have to sum it over all the possibilities of leaving state I. So you sum over all the possibilities of leaving state I, going from 0 to n, and we discount it back today. So these are the recursion relationship with the discrete case. Now let's talk about the two benefit. The characteristic of the benefit. Characteristic. It pays you for transitioning from one state to another. So it pays you for going for from one state to the other. So B continuous case. Okay, I'll discuss the general case. You have something like that. So in general, it is equal to like a sum. So in general, it is actually like a sum from going from a sum of transitioning from state I to state K, and as with, it is associated with a force of transition K to the state J, and once you transition, you paid a benefit B of t at time. So B of t is paid when you are in state J. Yeah. So B of t is paid on transition from state I to J, and this with all the sum of all the possibilities of that happening. Yeah, I already put the sum, but I want you to say integral here. So integral here, and this is discounted back today. So discounted back today, you have a sum of all the possibilities discounted back today from 0 to infinity v to the t sum of tpx ik, and the force of transition from k to j, and you are discounted back, and this is discounted back today, and you receive a benefit for that dt. This is like the general case, and the particular case. So particular case, it is when, for instance, you have a bar x ij, and this is equal to the integral from 0 to infinity, the sum of all the ways, of all the possibilities of transitioning from state state I to state J. So I put the K first, and now associated with the force of transition from K to J, Px, here Tpx Ik, and now this is discounted back today, here v to the t and dt. So this is like for the discrete case. For the continuous case for a benefit. Now in the discrete case, I'm going just to discuss the recursion. I won't go over the formula. So recursion for discrete case of the benefit. Recursion, discrete case of benefit. So with the discrete case, when you have the discrete case, you have something like that. Let's say ax ij. So axij. So at time t at at the beginning you already transitioning. So you go from state I to j. It is discounted back today, so you receive that money today. Or at time x plus 1, you're gonna be coming from a transition from a particular state K to a state J, and this is always associated with the probability of transitioning from state I to state K. And since it is 1 year from now, there's a 1 here, but it is invisible, so there is a 1 here too. and associated with all the ways of living the state I, and this is discounted back today. So to sum up, so at times you either receive a money, you receive like a transition from state I to J and you receive the money for that, or 1 year from now at you're gonna be age X plus 1, you're gonna come in from a transition from a state K to a state J, and this is associated with probability of going from a state I to a state K. And we have also to consider all the possibilities of living state I, and it is discounted back today. So this is IJ. Now for AXII. So at time 0 you're not going anywhere, you're still in the same position. So you have 0, but we assume that 1 year from now you're gonna be moving. So AX plus 1, uh, so you're gonna be transitioning from a state K to a state J. Uh, you have so you state I, you go to state K. All the possibilities of that happening is counted back today. So this is for the discrete case of the benefit. Now let already now I discuss the recursion for discrete case. Now let's give for example so example with the disability income model. So example of the disability income model. So the problem states that you have, let's say, 100,000 disability benefit, disability death benefit, yeah, 100,000 death benefit, 20 20,000 disability benefit. You have disability benefit. Nothing on transferring to disability. You have the premium is paid. Premium paid when healthy. When healthy. And it asks you to find A the premium, find the premium, find the premium. B assume that there is a 1 year elimination period. What is the new premium? New premium. And C, find the reserve. When it is healthy. When it is healthy at T equal 1. And D, find the reserve if it is unhealthy at T equal 1. So I'll put the problem on the side. Let's say to find the premium. So the situation is, so let me classify the information that I have. 100,000 death benefit. So this is translated. So it is paid on transition from being healthy to death. So I can translate it as like a bar because it pays on transition. So a bar, and it seems like we're playing with continuous case. A bar x going from state 0, which is healthy, to state 2, which is dead. Let me draw the diagram because we're playing with disability income model. So it will look like that. And then here, so this is healthy, this is disabled, and this is dead. So we can either go this way, that way, so 0, 1, and 2. So you go from 0 to 2, healthy to dead. You have that. Stage 2, 20,000 disability benefit. And the 20,000 disability benefit will be represented as it's pay for being disabled. So if you're not disabled, you don't get any money. So get A bar X. Going from state, it's like you go from a state 0 to state 1, from state healthy to being unhealthy at 0 to 1. And now the premium P is paid for being healthy. So it pays as long as you are here. So it will be represented for, so something that pays on being on the state is an annuity. So I'll represent it as A in bar 00, pays as long as you stay in state 0x. Now let's find, you're looking for the premium. What is the premium? According to the equivalence principle, expected present value of premium will be equal to expected present value of benefit plus expected present value of expenses. In this problem, we don't have any expenses, so this part is 0. So basically, it is expected present value of premium, which is equal to expected present value of benefit. Expected present value of premium will be represented as so these are the benefits, because disability benefit, death benefit. So A bar X 00. So you receive either a disability benefit or a death benefit. So either $100,000, so A bar X 00, or you receive a $20,000 for being disabled. So this will be represented as, this is the integral I just mentioned. So based on the formula from 0 to plus infinity of v to the t, tpx 00 dt. This is $100,000 time. So this a bar x is, so a bar x is will be equal to the integral from 0 to plus infinity to v to the t, all the ways of living state 2, v to the t, tpx 0 I, state I, and mu x plus t from I back to the state 2 dt, plus $20,000 integral from 0 to plus infinity v to the t, tpx 0 1 dt. So I'm gonna leave it like that because this is just a matter of integration. I'm not gonna compute the values, but just to give you an idea. And you solve for x or for t, but that part I want to emphasize that part. So the ways of living state 0. So you have state 0 here. You can either live by going to state 1. So you can do it this way, 0 2, and 0 2 you put a 0 here, or 0 2 you put a 1. You can either live by going from 0 or by 1. So I'm gonna write it as 100,000 integral from 0 to plus infinity v to the t, tpx 00, so 0002 mu s plus t 02 dt, or so the 100,000 multiplied by all of that, 0 to plus infinity from 0 1, so v to the t, tpx 01 mu s plus t 12 dt, right, plus 20,000 integral from 0 to plus infinity of v to the t, tpx 01 dt, and you solve for t. for P, you already have all those equations. Like all of these, you assume that it is given, and you can find P. A useful relationship for to solve this will be the fact that uh, e to the negative mt integral from 0 to plus infinity is nothing but 1 over m. Okay, so now they ask you, so they say assume that there is 1 year elimination period. So what is the new premium? So the same equation. So P a bar x 00 will be equal to $100,000 a bar x 02, right? Now, since there is 1 year elimination period, that means that if you are sick, so if you are sick the first year, it doesn't count. So we don't count the first year. So that means that for the $20,000, the death benefit, we don't count the first year. So we deferred our benefit for 1 year bar x bar 00. Yeah. So this is our premium, and we solve exactly as the other one. So let's call it P star premium for premium elimination. Premium of elimination period. The next question they ask you to find reserve when he is healthy. That means at t equal 1. So I have the graph like that, 0, 1, 2. So if at t reserve at t when he's healthy, 1 year from now, healthy, this is the state 1 year from now. So what is the reserve of that? So they ask us to find that answer. So 1 year from now, I'm gonna use the equivalence principle. You say that expected value of benefit. So this is our benefit. So it's if he is healthy, that means what? If he is healthy, pays $100,000 a bar x02. Now the elimination period. So we don't consider the fact that, so since he's already healthy, so pays $20,000. The first year he is not sick, so he doesn't receive any benefit, uh, disability benefit. So we're gonna defer it 1 year from now, bar x minus the premium. That means minus premium at elimination period, a bar x 00. So D, they ask us to find a reserve and healthy. So reserve when and healthy. So this is at t equals 1. So 1 year from now, reserve at t equals 1. Reserve when he's healthy will be equal to expected value of benefit, same thing. So 100,000, and this time we take into account like the first year he was sick, the possibility of him being sick the first year. So in that case, it's no longer deferred. So $100,000 a bar x 02. It can be and is an healthy at time 1, so you might receive a health benefit, a disability benefit, and name P star a bar x 00. So this was for the annuity and premium stuff. Now for the Thiele's differential equation. So Thiele's diff equation. So So for the discrete case, the discrete reserve. So Thiel says what? Reserve at time I of an individual age x t years from now. Reserve t years reserve will be equal to, so moving to, I'll call this part moving to state J, and I'll call this part staying in I. So moving to the state J, it will be equal to the sum. So you can move to state J. So if you move to state J, you receive a benefit. So you receive a benefit x plus t plus 1, since it is 1 year from now, for moving from state I to J. And this is always associated with the probability of going from state I to state J and discount it back to day. Or you receive, so that same reserve 1 year from now would look like this. That in another state will look like this. So 1 year from now, the reserve in another state will be associated with the probability of transitioning to that state discounted back to day. So plus t I to the j, we sum all the possibilities of leaving state I discounted back to day, minus, plus or minus, so plus a probability of staying in that state I, so it can be positive or negative, staying in that state I. And if it is positive, it is negative when it is a premium. It is positive in other situations. So if we put a negative on each side and we multiply the entire expression and we add on each side of the expression plus 1 v to the I x, we get this. So from this equation we will deduct the Thiel's differential equation that says that tx plus 1 v to the I minus, so the difference between the reserve today and the reserve 1 year from now for a particular state I will be equal to the derivative of that uh, reserve 1 year from now minus the benefit. So yeah, minus the benefit that you receive for being in state I. So the I's minus again the difference between being in state J 1 year from now and being in state I. The difference between being in state I and J 1 year from now plus the moving from one state, transitioning from one state, the benefit that you receive from going from one state to another, and all of that is discounted back to the, it is always associated with the probability ij, sum of all the possibility discounted back to the, and yes, so this is the Thiel's differential equation in a nutshell. So these are called that part the j's, this part the i's.